Okay, sharing my screen. I hope you're able to see my screen. Yes, no?
Yes, sir.
Okay, great. Thank you. So just do a quick recap of what we learned in couple of previous classes. So we learned about RAID, we learned about uh, business continuity and disaster recovery. We learned about a few new terms called RPO and RTO, and we understood, what are the different kinds of DR sites that companies set up, like near DR, metro DR, and far DR. And we understood that, in what kind of scenarios and how they architect these solutions based on criticality of data and distance of the DR site from the production site. We also learned that there are, apart from RAID, there are other data protection technologies like snapshots, backup, and replication. Snapshots is nothing but taking a photograph of your data as if it were at a particular point in time, right? And this kind of technology uses some additional storage space. They are not a full copy of backup, just pointers to old data, helps you to recover from data corruption, certain fragments of data corruption, somebody accidentally deleting a file, so on and so forth. Then we have backup. Backup is an extensive new technology where you have a separate backup server, and the backup server reads all the data, stores it in a different place in a separate format, and it allows you to do a complete recovery, but it can probably not give zero RPO or zero RTO. Then we have replication. Every byte of data coming into the first storage system goes into the second storage system. Okay. Now, so all these technologies that we have learned so far for data protection, they are to protect the data from unintentional failures, right? Why do I stress upon the word unintentional? Because those mechanisms are in place to still get access to your data when any component has failed, right? Or any accidental or unintentional deletion of data has happened, right? So be it RAID, be it snapshots, be it backups, or be it replication. Okay. But there are there is a people aspect to all this also, isn't it? So what is the people aspect to all this? Somebody may want to willfully sabotage or break in, okay, through all the security that may have been built in a data center just to cause harm, just to cause financial loss to the company, or even to steal data, okay, from existing companies. So that might be a competitor, okay. It might be a hacker trying to make a quick buck, okay, all these kinds of things. And the truth of the fact is, this is a 24/7 phenomena, okay. All the other phenomena you cannot predict, that's understood, okay, but it does not happen very frequently. It does not happen all the time. It happens once in a while, so you have to keep yourself protected from that eventuality. But when it comes to cybersecurity and data security, this is a 24/7 phenomena. Always there are attacks. Always, hackers are scanning the internet and the network to find loopholes, to find entry points into corporate systems, to break in and create havoc. Okay. So, what are the mechanisms we can put in place to make sure that we can be protected from hackers who want to deliberately cause harm. Okay, that's where the whole world of cybersecurity comes in. Now, we are just skimming the milk here. Okay, we are not going deep. Each of these concepts in cybersecurity has a very in-depth understanding to be done. So we are not going in-depth right now. We are only talking the basics just to make you understand what all concepts are available. Okay, each one of them will have a separate, what I would say, in-depth course, if you will. Okay, and we will learn about them in depth later. A little bit in intermediary course and more in the advanced courses. Okay, but right now we are just focusing on the basics. So when it comes to cybersecurity solutions, you can broadly classify them into two categories. One that works or at network level. Okay, when I say network level, these are either hardware or software or a combination of both. Okay, that get implemented along with the networking devices which connect the servers, which connect the storage, which connect the users, their computers, laptops and desktops, so on and so forth. Okay, so these get implemented at the network level, and then there are certain mechanisms that get implemented at the storage level. Okay, apart from these that are mentioned on this slide, there are many other technologies available which we will learn a little bit in the intermediary and more in depth in the advanced course. Okay, so there are many more technologies available at the network level. There are many more technologies available at the storage level also. Okay, but we will learn them later, not now. We have certain aspects written here, so we'll briefly touch upon them right now, not go in depth, just to make you understand what they mean and what is their purpose. So we'll start with some of the concepts in the network level cybersecurity, and then we'll get into the storage level. Okay. So first thing, what's a firewall? So as the name suggests, it is like a wall that you're creating. It is like a barrier that you're creating between customers' inside world and the outside world. Okay. Now, what is customers' inside world or the inside network? That's nothing but the customer's LAN. Okay. The local area network that has been developed inside their data center. Okay. And what is the outside world? The outside world is the complete internet. Okay. There will be applications that will be exposed to the internet, and exposing them securely through a firewall by applying certain policies. That is what, you know, is the function of a firewall. Okay. So basically, you can say that firewall is like a wall of a fortress. If you have seen some, movies, either Hollywood or Bollywood, depicting some old age, battles and things like that, you'll always see that a kingdom was always protected by a big wall. Okay. And just next to the wall, they'll dig deep trenches. And in the trenches, they always had the mechanism to flood it with water. And on water, they could always spill oil. And since oil would float on the water, when they lit it with fire, okay, people could not cross over and reach the wall. So that is where the term firewall came into picture. Okay, so they took it from the old age days. And in our context, in the context of network security, what basically a firewall does is it monitors each and every packet of data that is going out from the customer's internal LAN network to the internet, and it is also inspecting each and every packet of data that is coming from the outside world, which is internet, into the customer's internal network, which is the LAN. Okay, and it maintains these rules. Okay, a lot of rules. A firewall has a lot of rules, what to allow, what not to allow. Okay. And these rules are called as firewall security policies. Okay. Very simple. Okay. Every packet is inspected, whatever is going out, whatever is coming in. And for every packet, it will check with a predefined set of rules inside the firewall, what it should allow, what it should not allow. Okay. What it should allow to go out, what it should allow to come in. Okay. Both ways. So that's the function of a firewall. Now, firewall can be deployed in multiple ways. So you can have a software only firewall, and you can have a purpose built appliance called a firewall, which is nothing but a hardware where you have built in software inside it. What is a software firewall? You need a server, and on the server, you put the firewall software separately, and you make sure the network is designed in such a way that everything goes through that server. Okay. So that's the implementation of a software firewall. When it comes to a hardware firewall, it is nothing but a purpose-built appliance. It looks like a switch, but it's not a switch. So it will have ports where you can connect your internet traffic, ports coming from your internet service providers. And on the other end, you will have ports where you will connect your internal networking switches and networking equipment and all that. So every single packet of data going from inside the network to the outside world is checked, and vice versa. Any questions on what is a firewall? No? Okay, great. Let's move forward. Next, we talk about what is IDS and IPS. Okay. Now, this has got nothing to do with Indian Police Service. Okay. It is to do with cybersecurity. So, IDS stands for Intrusion Detection System, and IPS stands for Intrusion Prevention System. And both are two different things. Though they are most commonly referred to in conjunction with each other, but both are two separate things: intrusion detection and intrusion prevention. Okay. Now, what exactly is this? After firewalls were built, okay, hackers found a way to sneak in disguised as a genuine packet, okay, a genuine bunch of data or a genuine network connection to get inside a data center's network. Okay. But after getting in, they create havoc. Okay. So apart from a firewall, IDS IPS is an additional layer of security. Okay. Many a times, firewalls do not have the capability to understand if you join multiple packets, what exactly it means. Okay. It can detect individual packets, firewalls, but it cannot correlate all the packets to understand what this correlated thing is going to do once it lands inside the data center. And that is where intrusion detection comes in first. First, you have to detect an intrusion. Okay. So, what intrusion detection does is, after a firewall has checked whether a packet is genuine or not, all the packets that pass a firewall and come in, it will correlate those packets. Okay. And just see, after correlating and joining these packets together, packets of information, is something malicious going to happen. Okay. And how does it check this? They have got some signatures. They have got these IDS systems and IPS systems. They have some signatures of uh, how exactly hackers behave, or how exactly a malicious content will behave once it comes into the network. And for all these frameworks are already there. Okay. So, and these frameworks keep evolving. So IDS system will compare these packets with these existing signatures that it has, these existing frameworks that are there, okay, and try to understand if after joining these packets something bad is going to happen. If it detects that something bad is going to happen, it will stop the flow of the packets then and there itself, and it will notify the cybersecurity administrators that this is what is happening, so you can take some more preventive actions on the firewall to block that IP address or things like that. Okay, so those kind of things the IDS will do. Okay, and what is intrusion prevention? See, ID intrusion detection is only the detection process, and intrusion prevention is stopping these correlated packets to do something harmful inside the system. So it will drop the packet, or and it will block the firewall. It will not allow that information to be correlated inside the network. Okay, so that's what an IPS does. Now, in some advanced systems, this functionality of IDS and IPS is there within the firewall hardware and software itself as an additional layer. Okay, and in some cases, these are implemented separately. Okay, so firewall will be separate and IDS IPS system will be separate. Okay, but there are systems available where both these functionalities are conjoined together in a single system. That is also there. Okay. Then moving forward, VLAN. Okay, VLAN means virtual LAN, as it says in the slide itself. Okay. Now, why exactly a VLAN is required? VLAN is nothing but logical segmentation of the entire network. Now we all know that in IPv4, and if you are following the IEEE standards, you will have the 7 layers, and each device has got something called as IP addresses. Now in IP addresses, you know that there are subnets. Okay, in order for you to define certain groups of devices, so you can say all servers which are doing CRM software will form one subnet and hence will follow this IP address scheme. All other devices, let us say, which are there in the factory floor, they will have a separate subnet and they will form a separate scheme, so on and so forth. That's all fine, but if a packet comes inside after the firewall, after the IDS IPS, and even after passing the firewall, even after passing the IDS IPS, still there is some malicious content inside it. Okay, at the byte level, in order to control the extent of damage inside the network, or extent to which these hackers or malicious people can go in to the network, they have logically divided the entire network into something called as VLAN, virtual LAN. And each VLAN will get something called as a VLAN ID. Okay. And unless a particular device or unless a particular user has been deliberately given access to a VLAN, you cannot access the IP addresses and devices in that VLAN. Okay. So let us assume that a hacker somehow gets into the firewall, somehow bypasses the IDS IPS and lands inside the network. Okay, once they land inside the network, they probably will have access to a single VLAN, so only the devices that are there in those VLAN only that person can control, or that person can damage, and the other systems in other VLANs can still be protected. So you can limit the extent of damage by implementing this concept called VLAN. Okay, nothing but logical segmentation of the network, nothing more than that. And in VLAN also, when you're implementing a VLAN, these are also nothing but a set of rules and policies that you implement at the switch layer. Okay, so you have different kinds of switches called L3 switches and L2 switches. Okay, VLANing is something that you define on L3 switches, layer 3 switches, which will allow you to logically segment the complete network. Okay. Any questions on either of these topics? What is firewall? What is IDS IPS? What is a VLAN? Very simple. Okay, fine. We'll move forward. Okay. In our couple of earlier classes, we understood that there are specific kinds of devices to connect SAN storages to servers, right? And there you use a separate network. It is not the Ethernet network. You use a fiber channel network, right? So the same concept of VLANing, which we understood now, which is broadly applied in Ethernets, okay, which is TCP/IP protocol. The same thing getting implemented in fiber channel protocol, we will call it zoning. Okay, the same concept, just logical segmentation of the network at the switch level. Okay, but zoning is very, very specific to fiber channel protocol. Okay, it is not applied on TCP/IP protocol. It is applied only on fiber channel protocol, and that is called as zoning. Okay, and it helps in logical segmentation of a storage area network, SAN network. Okay, inside a data center. Moving forward, we talk about access control. Okay, now what is access control? When we are talking about access control, we are introducing two new terms. What are these two new terms? One is authentication and second one is authorization. Okay, authentication and authorization, both are separate things. Let me give a practical example in the Indian context. All of you have Aadhaar cards, okay? And what is an Aadhaar card used for? An Aadhaar card is used to authenticate whether you are an Indian or not. Correct? Just for identification purposes. It is a source of identity for all citizens. Okay? That's called authentication. So just to verify that you are the same person whom you claim to be. Okay? That's authentication. Then what is authorization? After a person has been successfully authenticated, that means you have understood that okay, this person is a genuine person and their ID proof matches what they are saying and what they are claiming. Then what level of access does that person have to some of the resources? Okay, that is called as authorization. Now if I have to give you an example of authorization, let us say banking. Okay, once you submit your Aadhaar card to the bank, okay, you have to authorize the bank to use your Aadhaar card to do something called as eKYC. Okay, which means you are authorizing the bank to use your identity information to gain access to the banking system. Okay, so as an end user of the bank, because I have been successfully authenticated using my Aadhaar card, and then because eKYC was done successfully, I am now authorized to use the banking system securely. When I say banking system, what am I talking about? I'm talking about the bank portal. I'm talking about how you're doing all your UPI transactions, how you're doing loans, insurance, all those things. Okay. Similarly, inside a data center, just like Aadhaar, okay, there will be a authentication server, okay, an authentication service, okay. In many companies, they use something called as AD, okay, Active Directory, where that Active Directory has a list of all the authenticated users inside the corporate. Now, for example, Infosys, right? So Infosys has how many employees? More than 1 lakh employees. So the Active Directory of Infosys will have entries for all those 1 lakh employees inside that Active Directory. Okay. And what does this Active Directory contain? It will contain the username and it will contain the password in an encrypted format. Okay. And certain other things which will help to identify that this person is the authentic person. Okay. Then comes authorization. Now, what is authorization? Through this Active Directory, once a user has gained access to a network, okay, you can define, okay, this so and so user has got access to which server, which desktop, which network, which software, okay, which other systems like HR system, payroll system, and you can also define what level of access, like whether this person is the super admin or not, whether this person has any rights to modify the settings, whether this person is having a read-only access to that system. Okay, all these kinds of how do I put it? Levels of access, okay, can be defined in that Active Directory. So Active Directory not only helps you to authenticate a user, it also helps you to define what levels of access can that user have for various hardware and software systems inside the complete corporate network. Okay. This is called access control. Now, I have really simplified this, but access control is one of the most critical components in cybersecurity. Okay. And every system in the data center will have to connect to this authentication mechanism in order to be part of that network. Okay, be it a laptop, be it a desktop, be it a storage, be it a server, be it a switch, anything. Okay, and hence, if an access control system like Microsoft AD gets compromised and a hacker gets some kind of a control or access into the authentication system, they can literally create havoc inside, because through that they can get access to the complete network, right, and all the devices. So the authentication system and the authorization system is a well protected uh, entity within a data center, and just a simple user id password is not enough these days, because that also passwords, as you know, can be broken. Okay. um, Even encrypted passwords can be broken. Okay, not a big deal anymore. And hence multi-factor authentication, MFA, okay, multi-factor authentication has come into picture. That means, as a user, in order to access a system, just giving my user ID and password is not enough. I have to give a few more details. Okay, like some websites use CAPTCHA. Okay, some websites say if you enable two-factor or multi-factor authentication, they say, okay, enter this code, okay, that will come on your app, or enter this number, or they'll say, go to this app and click yes, it's me. Okay, or sometimes Google says, identify all the bicycles in these pictures, identify all the cars in these pictures. All that is nothing but multi-factor authentication. Okay, one, to determine you are a human or not, and second, if you are a human, you are the correct human who needs access to those resources. Okay, it is, you are not duping, or you are not disguising yourself as someone else. Okay, so this access control and identity control itself is a big thing in cybersecurity world today. Uh, we will learn a lot more about it when we talk in the advanced course. Okay, not today. Any questions on what is access control, what is authentication, and what is authorization? I'm only telling you about very high level stuff, not going deep. Any questions? No? Okay. Moving forward, the next concept is called as LUN masking. Okay. Now, what exactly is LUN masking? Now, before we understand what is LUN masking, we have to understand what exactly is a LUN. LUN is nothing but a logical unit number, and it is used specifically in SAN, not in NAS. Okay, only in SAN you have this concept called LUN. Now, what is a LUN? We understood that a storage system has got huge amount of storage space created due to adding hundreds of hard disks or SSDs together. And on these hard disks and SSDs, either we can apply RAID for data protection or we can apply erasure coding. And we learned what is the difference between both of them, right? They are used to protect the data from hard disk failures, right? Now, after RAID or after erasure coding has been applied on multiple hard disks, you get this bulk storage space, right? Now, this bulk storage space, you can further slice it into logical partitions inside the storage itself and then give these slices to a particular server. Now, for example, I have 100 hard disks. On those 100 hard disks, I created, let us say, RAID 6, and I got a complete storage space of, let's say, 500 terabytes. Okay. Now, out of this 500 terabytes, I want to give 50 terabytes per server. Okay. Server 1 should get 50, server 2 should get 50, so on and so forth till server 10. How do I do it? So, after creating this 500 TB volume, you further can slice it into logical segments called as LUNs. And each segment is given a unique number. Okay, and that's why the name logical unique number. Okay, LUN stands for logical unique number. Okay, and each of that slice is called a LUN. So LUN 0, LUN 1, LUN 2, so on and so forth. Okay, and by default, if you do not have this concept called LUN masking, any server that is connected to the storage system can have access to all the LUNs in the storage. Okay. Now we took this example, right? That I have created a RAID out of, let's say, 100 hard disks and I got 500 TB worth of volume. My requirement was each server should get only 50 TB. But if LUN masking was not available, server 1 can also see 500 TB, server 2 can also see 500 TB, server 3 can also see 500 TB. Now, how do I make sure that server 2 doesn't mess with the data of server 1, server 3 doesn't mess with the data of server 5, so on and so forth. And that is where LUN masking comes into the picture, where even though the same storage system, the same hard disks are physically connected to all the servers in the network, okay? But when they see and try to access the storage, they will find only those slices to which they have been masked. Okay, so this 500 TB, when I slice it into 10 different slices of 50 TB each, I can say, okay, LUN 0 can be accessed only by server 1. Okay, that's all. Very simple. LUN masking is that much only. Okay, you after you create that slice, and that slice is called a LUN, and that LUN has been given a LUN ID, you can tell the storage system that, hey, Mr. Storage Controller, this LUN 0 can be accessed only by this particular server called server 1. Okay, and hence when server 1 tries to access the storage, it will see only that 50 terabyte coming from LUN 0. That is called LUN masking, even though physically it has access to all the other LUNs in the storage system, all the other volumes also. So that's called LUN masking. I'm not getting into The details of what is HPA, host bus adapter and all, that we'll discuss later, okay, in our intermediate course. But this is basically what is LUN and what is LUN masking. Any questions? Any doubts? No? Okay. All right. Then we get into the next topic, which is called as data encryption. Now, encryption is a technology which got invented during World War II. Okay. What happened was the Germans were very clever. Okay. They intercepted the telegraph lines of UK during the World War, and whatever the various what are they called in army, the various were discussing with each other. They were able to understand, and they were able to uh, go and either capture their base, or kill all the soldiers, and create a lot of damage. So that is where, but Germans, they wanted that their communication should not be heard by anybody else. Okay. And that is where they brought in a technology called ciphering. CIPHER, cipher. Now, what is a cipher? We used to play these puzzle games, right? If we have an English letter, English alphabet, if I say that A is 1, B is 2, C is 3, so on and so forth, Z is 26. Okay. That's the simplest form of a cipher. Okay. Where if I have to say BOY boy, I will say 2, then whatever O stands for and whatever I stands for, and send that number rather than sending BOY boy. So anybody who does not understand this coding, okay, will not be able to decrypt the data on the other side. So like that, they created very complicated ciphers, and they used to apply these ciphers on human readable language and send the encrypted data or the encrypted text to over the network to the recipient. And only since the recipient knew what is the mapping, okay, only they can decrypt it. So that was the birth of encryption technologies. Okay. And encryption technologies really evolved a lot over the last many decades, and it became very, very complicated. And it went to the level of something called as 256-bit encryption. That means for every packet of data, you could apply a 256-bit cipher, okay, to that packet, and encrypt it so much that by normal brute force, okay, if you had to decrypt it, it would take millions and billions of hours. And even if you are able to successfully decrypt after those many number of hours, that data which you have decrypted will not have any logical sense, or the context to that information may have been lost. Okay. So that's the role of encryption. And encryption is still used today. Okay. I'm not saying no, it is not used. Okay. But it does not take millions or billions of hours to do even 256-bit decryption today. Okay. By the by using AI algorithms and bots and not humans, uh, even 256-bit encryption they are able to break, on the fly. So even though data encryption was predominantly used for transferring data securely over internet and within local networks also for good 4 or 5 decades, I would say, or even more. But slowly and steadily, encryption is going away. Okay. And newer kinds of ciphering are coming in. um, and they are using quantum technology to do that. Yes, it will take time to adopt, uh, because data encryption has been there across all software and all hardware in the form that we knew all these years. And to replace all of that, it's going to take time. But until such time, we will still, whenever we still refer to encryption, we will refer that only, that traditional method. And whenever we find a newer way, I will kind of point it out to you that this is the newer way of encrypting the data. Okay. Any questions on what is encryption, where it is used, how it is used? Okay, no more questions. So we move forward to the new topic. This topic is called as GRC, governance, risk, and compliance. All right. Now, as you know, in any business, in any company, it's not just technical people who are there, right? There are people who are lawyers, there are people who are managing the legal things, there are people who are managing the financial things, there are people who are dealing with the governments. Okay, all these things are there. And many a times there are also cross-border transactions. What I mean by cross-border transactions is there is money and data that is moving, and even people who are moving from one geography to another geography. And when such a thing is happening, the company, the IT company, or the people who are running the IT systems, they have to maintain the regulations of the country where the data is residing, as well as they have to maintain the regulations of the country where the data is landing in, okay, or where the data is going. Okay, both are important. And this GRC, governance, risk, and compliance, is like a umbrella structure or an umbrella framework, okay, for all kinds of digital systems uh, in the company, which will talk about who should handle the data, what is the classification of the data, that means categorizing them into most sensitive to least sensitive, okay, and how to protect the data, and how to make sure that all the systems, all the software, all the hardware, okay, and all the data residing in these systems is compliant to government rules and regulations of the country where the data is residing, as well as the country where the data is going, okay, or where the data is being accessed, both. Okay, so there are these software available out there in the market who can go inside your IT systems and scan all your software, all your storage systems, all your servers, all your networks, and can give you these reports called as audit reports, which will tell you from a GRC perspective, governance, risk, and compliance perspective, how you're faring, and it'll give like a mark sheet. Okay, it can tell you, okay, this part of data which is highly sensitive, okay, it is compliant or non-compliant against this law or against this rules and regulations. All right, or it can identify that, okay, this high risk data is there. Approximately 100 users have access to this data, but out of these 100 users, 5 users are there who have full super admin access to this data. Okay, and hence that is high risk. So do you have mechanisms to curtail that risk? What if one of those person copies that data into a USB drive and leaves? Okay, and see, trust me, all these things keep happening in the world today. Okay, for example, Pepsi always wants to know what Coke is doing, and Coke always wants to know what Pepsi is doing. Okay, so they always try to hire people from each other's companies so that they get access to this confidential data. Now, it is the job of the IT team and the GRC team to make sure it doesn't happen. Okay, so they identify risk and make sure that such individuals, something called as data leakage prevention is implemented, so that they cannot copy corporate data on email, they cannot take screenshots, they cannot copy it on USB, they cannot copy it from one network to another, they cannot access their personal email ID. So all these kinds of restrictions can be applied to reduce the risk. Okay, and then governance. So if let us say there are few super admins in the entire company, who is monitoring the super admins? What if the super admin becomes rogue? One of the super admins becomes rogue. Then what? Okay. So how are you applying certain governance policies on not just every other user but also on the super admins? Okay. So all this comprises something called as GRC. Uh, we are going to learn a little bit about GRC in our intermediate and advanced course, but we are not going deep into it. Okay. And today, many cybersecurity providers, many backup vendors, okay, are providing these GRC capabilities within their software itself. Okay. Which means you don't have to necessarily purchase a separate piece of software or separate softwares altogether to do this. Okay, uh, the industry is at a stage where all this consolidation is happening. Okay, now there is additional reading material here which I will provide to you on WhatsApp. Okay, and just go through it. Is mostly English. Okay, little bit of knowledge check. Which of the following concepts is the ability of an organization to continue its business operations after or during a disaster or disruption? The options are data recovery, data governance, data compliance, or business continuity. Please post your answers in the chat box. D. Hari says D. Very good, Hari. That's the right answer. Yes, it's called business continuity. Okay, so we come to the end of this course where we have understood how to protect the data both from component failure and also from outside and also from internal threats like somebody trying to sabotage. Okay, great. So any questions on what we have learned so far on data protection? Though we have just learned the basic concepts. Any questions? No? Okay. So we're gonna do next is apply this knowledge for cloud. And we understood what cloud is. It's nothing but the same thing that is there in the data center, but when we are trying to use it, we are trying to use a slice of it and as a pay as you use financial model. Okay, so little bit we'll go into the depths of cloud computing and try to understand what are the various terminologies and uh, understand what are the concepts that go into it. Yes, so here we introduce a new concept called public cloud, private cloud, and hybrid cloud, and we'll talk about what that is. So first itself, there's a question. What exactly is cloud computing? So this is the NIST definition. So what is NIST? As you can see here, National Institute of Standards and Technology. Okay, NIST. So this is from US Department of Commerce. It's a subdivision there. And what they do is for the IT world. Okay, IEEE was the for the telecom world. There is another organization called SNIA, SNIA, that's for the storage world, storage and networking world. And then we have this called as NIST, NIST, National Institute of Standards and Technology. Okay. So what NIST does is it gives guidance, it develops frameworks, and it asks all the manufacturers of hardware and software and people who are building new protocols, the scientists, to follow certain standards and frameworks so that it does not become proprietary for anyone and it is as open as possible. Okay. Now, what is NIST's definition of cloud? So it says that cloud computing enables ubiquitous, convenient, and on demand network access to a shared pool of resources. Okay, shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Now, a lot of English. Okay, so let me try to simplify this in much more simpler terms for you. So, with the help of an example like mailbox. Now, we understood that email is nothing but a workload running on certain servers, right? Now, if a user has to access their mailbox or create a new mailbox, what should happen? Some amount of CPU and RAM should get used, number one. Number two, some amount of storage should get used. Number three, it will also use the network. Then identity or access control should be applied on it. User authentication and authorization should be done on it. Then all the traffic flow from the internet to your laptop and vice versa, it should all be encrypted so that you know your data should not be stolen. All these things are there. But tell me one thing. When you created your first mail account, did any other user from Google or Google's employee or Yahoo's employee or Microsoft employee come on a call and help you configure it? No, right? You did it all on your own, right? Because all the steps are predefined, okay? And it is a kind of a self-service mechanism or a self-service mode, right? So that's the last two sentences or last two sections of this sentence. Okay, with minimal management effort or service provider interaction. So this is one characteristics of a cloud. Okay, any service on cloud, it should be given to the end user with minimal management effort or service provider interaction. That means the user should be able to deal with it by themselves. Okay. Second thing, when you're creating your mailbox, after you do all the steps and when you click on create, you have given all the information that is required, okay, by Google or by Yahoo or all these mail providers. Does it really take time to start using your mailbox? No, right? You are getting it instantaneously. Okay, even less than the time it takes to prepare Maggi noodles, right? Instantaneously, right? So rapidly provisioned, that is one more characteristic. Okay, as you can see here, whatever is the service, right, after the user has given their request and all the necessary information, okay, that service should be available to the end user rapidly. There should not be any delay. Okay. And second thing is, when the user doesn't want it anymore, you're deleting your mailbox. You are saying you delete my Google mailbox account or your Facebook account or any of these accounts, right? Instagram account. It should be released also instantaneously so that those resources which your account was using can be then shared with someone else who wants it. Okay. So not only should the provisioning happen instantaneously, even the release should happen instantaneously. Okay. So that is the next characteristics of a cloud. The third characteristics is it should be configurable. Okay. What do we mean by this? The user, the end user, who is the consumer of the service, should have the choice and the freedom to select how much they want and for how long they want it. Okay. For example, when you're selecting your mailbox, if it's a free account, right, there is a limit, right? 5 TB or something. But when you go to a paid account, that limit increases, and there are multiple versions of that paid account, right? So for this level, where advanced, you have this. For enterprise, you have this, so on and so forth, right? So it should be configurable, right? And as and when you choose a different kind of a subscription, the amount of resources that get allocated to you keep changing, right? And it is up to you to choose from the existing subscription plans that the service provider is providing to you. All right. So this is the third nature. Okay. This is the third nature. And what are some of the other natures or other characteristics of a cloud? These. Okay. It should be ubiquitous, it should be convenient, and it should be on demand network, which means ubiquitous means what? Always available, 24/7, 365 days. Okay. Have you ever heard that Google has gone down? Have you ever stopped using your Gmail boxes? No, it's always on, isn't it? So just imagine. So, whatever is the infrastructure behind it, do you think nothing has ever failed? Impossible, isn't it? Some things will definitely fail. So you have to design your server, network, storage, security, backup, all these things in such a way so that this cloud service called as a Gmail can never ever go down. Okay? Always on, always accessible, and always all your data is available. Okay, however old and however new it is, right? So that's ubiquitous. Convenient, you can access it as long as you're connected to the internet, right? You can access it on your phone, you can access it on your tab, you can access it on your laptop, you can access it on your server. Now you can access it even on your watch, on your smartwatch, right? So it is convenient and it is on demand, right? So whenever you want it, you can access it, right? So this is how we define and try to identify what are the characteristics of any cloud service. Okay, any questions on this? No. Okay, let's move forward. Okay, so the first thing that happens in the cloud is called as creating something called as a shared pool of resources. Okay. And this is where we introduce a few new concepts, and these concepts are the basis or foundation of cloud. Okay. Without these concepts being invented, cloud itself may not have been born on the internet. Okay. Now, what are these? A few classes earlier, we understood what is a storage, what is a server, what is a network. Okay. And we also understood that in a given data center, all these hardware components are available at a massive scale, right? When you go into a large data center, you will see hundreds of servers, probably thousands, tens of thousands of servers, then petabytes and petabytes of storage across various storage systems, and millions of network ports and cables, okay, connecting all of these together, right? But when I want to create such a cloud with these kind of characteristics, that it should be always on, it should be self-service and all that, I cannot host that service on a single server, okay? Because if anything were to happen on that single server, then that entire service would come down, right? So the IT world, okay, brought in a layer of abstraction between the hardware and the workload or the software. Okay, in between, they introduce something else, and that something else is called virtualization. Okay, it's called virtualization. Let me put it up here for you. It's called virtualization. And the software which actually helps you virtualize or abstract hardware across multiple servers, and we are not talking about single server, okay? Or we are not talking about a single storage or a single network. We are talking about hundreds of them coming together and forming shared pool of resources, okay? So the software which allows us to do this is called a hypervisor, okay? It's called a hypervisor. Now, some examples of hypervisor are VMware ESX, okay, OpenStack, Citrix, XenServer, Microsoft Hyper-V, okay, Red Hat, OpenShift. Now, one more thing which is very popular is Proxmox, okay. All of these are hypervisors built by different companies, okay. What they do, very simple. They take resources from all the servers, like they put all the CPUs put together. Now let us say I have 100 servers, and each server has two CPUs, okay? When you apply this hypervisor on top of all these servers, before you load your software on them, you will actually have access to 100 into 2, 200 CPUs. And now you can create something called as a virtual machine, okay, which can have more than two CPUs allocated to it. Do you think this would have been possible if virtualization wouldn't have been there? If I am deploying, let's say, my website software only on a single server, I can only have access to that many CPUs which I can have, which are possible on that hardware, isn't it? I cannot go beyond it because that's a physical limitation. But when you install this hypervisor and you're collating all these resources together, okay, I can do a lot more. Okay, I can make this software run simultaneously on multiple physical hardware. Okay, and that's the beauty of a hypervisor. And it can do not just with CPUs, it can do it with RAM, it can do it with network resources, it can do with storage resources also. So all the layers of a data center which we learned, okay, a hypervisor is capable of virtualizing or abstracting all these layers. Okay, of course, each hypervisor has its limitations. They have their best practices and compatibility, also hardware compatibility. Not all hypervisors can run on all kinds of hardware. Okay, there are certain limitations. Okay, so that we will learn a little bit in the intermediate class, and then a lot more detail in the advanced class. Okay, and we will learn a proprietary hypervisor, like for example VMware or Hyper-V, and we'll also learn open source hypervisors like OpenStack and Proxmox. Okay, so both we will learn, so that you get a good feel of both of them. But have you understood this basic concept called virtualization? Any questions on what is virtualization? Another practical example that I can give you is when we live in apartments, right? What are we doing? We are exactly doing something very similar. It was one piece of land, but being shared by multiple people, and all the resources are being shared, right, on demand. Whoever needs how much electricity they are getting, whoever needs how much water they are getting, security is there. Okay, whatever you want to store in your flat, nobody is coming and asking you what you're storing in your apartment. Okay, of course it should be legal. Okay, so like this, right? So that's a very simple example of virtualization. Okay, you have virtualized the piece of land so that multiple people can start using it. And that is where we bring in the concept of multi-tenancy also. So these common or shared pool of resources can be given access to multiple users simultaneously. And that is where the third thing also comes in, that the IT people who have actually set this up, okay, it is not necessary that they have complete control on who gets how much and who gets what. Okay, so for example, does the Google's IT team have control on what kind of mailbox are you going to create? No, it's up to your wish. Yes, there are guidelines, there are maximums and minimums, and there are frameworks. But within those frameworks, you're free to do whatever you want, right? So that is what it is. And then last statement is very, very important. Okay, this one. Okay, as an end user, you are not sure, or you don't even know, or you cannot even control where exactly your data resides in all those servers and storages. Okay, that is solely in the control of this software called hypervisor. Okay, you can create boundaries, all that is possible, but within those boundaries, only the hypervisor is aware whose data is where. Okay, nobody else knows that. Not even the IT team can tell you whose data is on which server. It's not possible. Okay, any questions on this? And this forms the basis of cloud. When these concepts are deployed inside a data center to be used only by the people of one company, it's called a private cloud. And these VMware, Hyper-V, all these software and hypervisors that I mentioned, these are exactly the ones that are used to build a private cloud. Okay. Then if a particular software needs to be given to the public at large, okay, across billions of users all over the globe, that becomes a public cloud, like AWS, like Microsoft Azure, like Google Cloud, DigitalOcean, Alibaba. All these are examples of public cloud. Okay. Then what is hybrid cloud? When a company uses a percentage of private cloud and also a percentage in the public cloud together. Okay, to achieve their business purposes. It's called a hybrid cloud. Very simple. Okay. Any questions on this? What is public, private, and hybrid? So I will go a little fast on this. We have already understood that it should be rapidly provisioned with minimal management effort, can be programmed for self provisioning. Okay. All this is automated. And whatever be the need of the cloud should be able to deliver. Okay. Whenever we want to grow, you can scale, you can add resources on the fly. Okay. Cost flexibility, you pay for only what you use, and then consistency of service. Then we have containers. Containers are nothing but further smaller elements inside a cloud to run your software. Some people call it a virtual machine, some people call it a container. Okay, yeah, both are different things. We will understand in a little while. Yeah, so these are some names of containers. Now, who can tell me in our class what exactly is the difference between a virtual machine and a container? Anyone? Anyone? And you can refer Google, you can refer AI also. Okay. Can any of you tell me what exactly is a container and how is it different from a virtual machine or any other server as well? All of you are searching Google.
Sir, containerization means it will contain set of virtual machines.
Set of what? Sorry.
Set of virtual machines and services.
No.
And
Okay. Let's take it step by step. What came first? Let me stop sharing for a while. Okay. What came first? Did virtual machines come first in the IT world or did containers come first in the IT world?
virtual machine.
Correct. And containers came in to solve certain problems with virtual machines, right? That's how technology advancement happens, right? So if we understand what are those problems of running a virtual machine, we can understand what exactly a container does. Simple. Okay. Right. So let me break it down for you. When you're creating a virtual machine out of shared resources from multiple servers, multiple storages, and multiple networks, you are going to define, okay, this virtual machine is going to have how much CPU, how much RAM, what network access it has, and how much storage should be allocated to it, right? But is that enough to run something inside that virtual machine? No, you have to add one more layer called as operating system. Okay, without an operating system, a virtual machine, even if you create, is of no use because you cannot load any software on that without an operating system. So many of these hypervisors like VMware, Hyper-V, okay, OpenStack, Proxmox, okay, or Zen Server, at the time of creating the virtual machine, they will ask you an additional question. Okay, what is the operating system that you want to deploy in that virtual machine? Is it going to be a Linux based operating system? Is it going to be a Windows based operating system? Okay, why? Because as we understood in some of our earlier classes, depending upon the operating system that you choose, some limitations get applied. What kind of limitations? Maximum number of CPUs, maximum number of RAM, maximum partition size, maximum volume size, Okay, all these restrictions get applied. The type of file system, okay, all these restrictions get applied. And hence, it will allow you to create a virtual machine which is optimal for running that particular version or type of operating system. And once this entire virtual machine is created with CPUs, with RAM, with network, with storage, and the operating system, then when you log into that virtual machine, you can deploy whatever software, because after that, you will not find any difference between a physical server and a virtual machine. The look and feel, everything will be absolutely, or I would say more than 98% the same. Okay, what all operations you were originally able to perform on a physical server and an operating system deployed on a physical server, more or less most of it you will be able to perform inside the operating system of a virtual machine also. Okay, but as and when the world is advancing, and as and when the behavior of users accessing cloud is changing over a period of time, people have understood that deploying software inside the operating system of a virtual machine, one, it is becoming very, very costly, and second, scaling and descaling rapidly is becoming a problem. Okay, scaling and descaling rapidly becomes a problem. Okay, see, it takes good amount of time and resources to bring an operating system up and online. Okay, it takes few minutes, it's not instant. Just think, okay, how much time does it take for your laptop to boot up? Okay, now this is just a small laptop. Just imagine how much time it will take for a big server to boot up. Okay, it takes time. But if you look at user behavior today, nobody has time to wait. Okay, unfortunately, everybody wants everything instantaneously. Okay, so if I have to bring up a new instance of a database, if I have to bring up a new instance of my web portal, if I have to bring up a new instance of my software, immediately, rapidly, just like that, without impacting performance. In fact, it should increase performance also, very rapidly. Then deploying that software inside an operating system, inside a virtual machine becomes very cumbersome and costly, and it also degrades performance. Because of this, containers came into existence. Okay, why and what purpose do containers solve? What is the purpose of the operating system there inside a virtual machine or in the server? It is a layer of abstraction between the hardware elements and your software. So whenever the software says, okay, I want to run this, the operating system allows to run that instruction on the respective layer of the hardware. Instructions for CPU, data to be put in RAM and then persistently stored in storage, then communicating data packets securely over the network. So all these things are taken care by the operating system. Now, what if the software deployed inside a container can directly speak to the hardware? Do we still need the operating system? No, we don't, right? Because that layer of abstraction is now being provided by even more lightweight, nimble, piece of software. And that very lightweight, nimble piece of software that allows you to run your applications as services, okay, not as virtual machines, okay, as services on a shared pool of resources. That's called a container. Okay, so in a container, you will not have an operating system at all. Okay, you will directly create something called as a container image. That image will have the application inside it, and it allows you allows that application to directly interact with the shared pool of hardware resources lying underneath. So there is no role of operating system anymore. Okay, and that's exactly what is a container. And these are some of the most popular container services available out there. Okay, and one popular myth, I would say, or misconception is people think that Kubernetes is also a kind of a container. Okay, but it is not. Kubernetes is not a container. Kubernetes is a container management software. It allows you to manage the containers. It allows you to create new containers, delete containers, resize the containers, create some policies as to, okay, if the load is higher, how many new containers should spin up? If the load is lesser, how many containers it should delete? All those kinds of things, the life cycle of a container. Okay, it allows you to do all that. But Kubernetes itself is not a container platform. It's a container management platform. Okay, so you'll have to understand that. Any questions on what is a container now? Is it clear? So knowledge check. Let us see how much you have understood. So this is with the NIST definition. What will go into the first blank? Cloud computing enables ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. So all the characteristics of a cloud. Okay, so that is what it is. So any questions on whatever we have learned today on cybersecurity concepts, virtualization concepts, container concepts, cloud concepts? Okay, now each one of them, obviously, there is a lot more to learn, and knowing each one of them separately also can give you a job. Okay, you don't have to be good at all of them. Yeah, this is one more, so I'll just go forward quickly. All right, so we will get into this cloud computing framework tomorrow. So any more questions on what we have learned until now? No? Okay, fine then. Thank you so much for joining. We will meet again tomorrow. And as I said, we are coming to the end of the basic course. And after the basic course, we'll just take a few days of gap. And then we'll come back and start with the intermediate course where there'll be more practicals to be done. Okay. Thank you so much. See you all tomorrow. Bye bye.